Welcome to the chat, my friends. Uncle said hi. Welcome to the platform. Welcome to the platform. As we can see people here. Today is another day that we need to discuss serious matter that people requested. It's important. Hi, Jamaican Uncle. Welcome to the chat. And we introduced cancer yesterday. Blessings to you, Benjamin the Ice Guy, and everyone who is in the chat. Blessings to everyone who is here. So today is another day that we start. Yesterday we introduced Bibi Shosh. Hello, doctor. Welcome to the chat. It's a special day of discussing some issues that are important in the life of a person. And today we are discussing breast cancer. We're discussing breast cancer, which is something that has disturbed so many people, and it has been a very funny thing that even some cure has not been got. You know, we introduced cancer yesterday, and everyone that cancer comes from our own. Cancer comes from our own composition in the body. So if you are new, please like. We have just started. If you are new here, just click the subscription and like the video so that you can be getting some more impressions. Or when you want to go, so we are live, you can come and ask any question that you really need to ask. But here we discuss matters concerning health, and we discuss issues that are affecting the people. So we introduced cancer yesterday, and we said it is a mutation. It is caused by a mutation at the level of cancer is caused by a mutation at the level of differentiation, or at the level of when the cell wants to integrate or fuse, or when the cell wants to divide, then you get cancer. We saw several types of cells of the body. You remember epithelial cells, fibrotic cells, all those cells, nerve cells, blood cells. You remember all those cells, like platelets. We talked about platelets. We talked about other cells like the bone cells, osteocytes, osteoblasts. All those types of cells can be affected with cancer. And it is important every time that when you go through some documentaries or some things concerning cancer, just know that cancer comes from cellular level. Cancer is a disease that originates from cellular level, the level of your cell. And we said the body is made up of cells. This body is made up of cells. Your skin is made up of cells. Your bone is made up of cells. Your intestines are made up of cells. Adipocyte layers under the skin are cells all. So when it comes to cancer, we talk about the cell. Miss Marie, hello Benjamin, hello, welcome Miss Marie. Today we are talking about breast cancer. And I will put up something here, and to check this out, to ask the people if you think cancer is breast cancer is let me check if we can do this. Do you think breast cancer is do you think breast cancer is for men alone? This one, where is this thing here? Do you think breast cancer is for men alone? Touch, create, highlight. Okay, something I want to note that one. Maybe shush, come on. Effect, flip. There's something that I want to, I'm looking for, but I'm not finding it. Create, highlight, flash. Okay, create it as we go on. I will ask, do you think breast cancer can affect women alone? Because most of the populations that are affected with cancer, breast cancer, especially breast cancer, are women. So that will be the question of the day. Do you think breast cancer affects women alone? And have you ever had a man that has breast cancer? So when we go through some recap of what we did yesterday, because we talked about cells of the body, and the cells of the body are the ones which can be affected so that you can get cancer. You get? So let me go through some cells of the body, so that when we are talking about breast cancer, we know which type of cells we are talking about. And the question of the day still remains: do you think women alone are the ones which are affected by cancer? Now, yesterday we introduced type of cells like epithelial cells, which are covering outermost, the ones which protect you inside and out. They are called epithelials. We say it's squamous, cuboidal, columnar, ciliated, and glandular. Epithelial cells are cells of the body. We say nerve cells, muscle cells, because you have muscles and muscles are made of cells. We saw blood cells. Connective tissues are cells. Connective tissues like adipocytes, fibrocytes, osteocytes. I said when you hear about osteo, I'm talking about bone. Bone is a cell, so it comes from osteocytes, osteoblasts. All those are cells. Macrophages for immunity, those are cells. And then we talked about reproductive cells. Reproductive cells are sperms and ovums. Those ones, they undergo a different kind of reproduction that is called meiosis, not the normal one that we know, that is mitosis. They have two ways of multiplying. You get? So we go to the stem cell, which is the cell that is when you get leukemia, most of the time this is what is affected. Embryonic stem cell can differentiate and become any cell, can form any cell type. They are called pluripotent. They can form any type of cell. So when your cells like the macrophages are low, the embryonic cell produces and they become they can form any type of cell. And then you have adult cells that are in your bone marrow. In your bone marrow, there are some adult cells in bone marrow and other tissues. I'm just going through the recap of the day. The bone marrow, Maureen Kawila. Let me read today. Now, Maureen, today is the day of women, because I'm talking about breast cancer, and is breast cancer disease of women alone, or do even men, as we continue, you can answer that question, or even men can get breast cancer? Is it for women alone, or can even men get breast cancer? Hello, get a sticker? No, don't want a sticker. I want to post that question there. Top messages. I want to post that question there. So is it a disease of men and women, or is it that women are the ones who can get breast cancer only? So there is something important that we talked about of concerning cells, and I repeat so that when we are studying, Maje, welcome to the house. Welcome to the house of health education. Welcome to the house of health education. There is something important that I want to repeat today, and so that some people can, getting a recap is important. Getting a recap is important. This is your cell, and inside the cell you have the nucleus here. Now inside here is where your DNA is. Now, Bibishoch, I thought it was for women alone. Bibishoch, it's a question I'm asking. Do you think this is a disease for women alone, or it can affect? It's a question I'm asking that we will answer as we finish our topic. So if you are coming in right now, you can answer that question. Do you think breast cancer is for women? Yes, men can be affected as well. That is an answer from Maureen Kawila. Any other? Let's make it happen. I'm not sure, doctor. You see, even Bibi is not sure, but at the end of the talk, she will know what is the answer. Now, inside the nucleus lies the DNA, and we say the DNA has chromosomes, the ones that I want to draw here. The DNA has chromosomes, the ones that I want to draw here. The DNA has chromosomes, the one I want to draw here, so that I'm not sure, yes, Bibishoch, you will be sure today. You will be sure today. Maje, greetings. Maje, do you think breast cancer is for women alone, or it can affect even men? Do you think breast cancer is for women alone? There are some things I'm drawing here that are very important, that are guanine, thiamine, cytosine, and adenine. Guanine, thiamine, cyanide, adenine. What do you think? Benjamin the wise guy, everyone, hello everyone. Johnny be good, thank you so much for your support. And as we come in, please remember to like, so that we get more impressions, So there is something I'm drawing here, so that it can make an understanding, as we talk. I know of a man that got breast cancer. You see, I'm preparing something so funny, so that when we are studying, you can appreciate. It is important. Live, love, herbs and spice is here. So so that we can know, to adenine, cytosine. Just keep waiting a lot. I'm preparing something that is very important. Cytosine. Very important, so that when you study, and if you have a question today, Elmarie Speed, Elmarie, hi, welcome to the chat. Do you think breast cancer affects men alone? Kingsley, welcome. The ninth. So this is a recap of what we studied, and it's very important. Now this is your cell. Any cell type, this is your cell, and inside you have some things that are called chromosomes. Inside you have some things that are called chromosomes. So these ones are the chromosomes, and I've drawn them here. Now the chromosomes, they carry your DNA. Now the DNA is this one part that is very long, but you are something. Hope I'm audible enough. Hope everyone is listening, and you are going through the topic. Hope everyone is listening and you are going through the topic. Now look here. This strand that I've drawn is one of this strand. So there are some nucleotides and proteins that are called guanine, thymine, cyanine, adenine. These ones are the ones which make your chromosome, and your chromosome is made up of the DNA. The DNA is inside the nucleus here. One of these guanine, thymine, adenine is replaced by something else. The sequence is changed. That is where we say cancer has started. Look at it. So this is one strand of this, and you see cytosine binds to guanine. As we continue, thymine binds to those are proteins. It's a sequence of proteins. That's how they bind. So one of the protein, if one of these protein is replaced by something else, maybe we say cytosine comes to thymine and thymine goes here, you will find that this will be a mutation. And that's where we start having what? That is where we start having cancer. Cancer starts from the cell. So wherever type of cancer that you are undergoing, it means it is at the cellular level. So cancer is named after the cell that is being destroyed, or mutated cell that is producing a funny cell. So here we are talking about if a cell of a bone, osteocyte, has a problem, we will say you have osteosarcoma. You get? Now let's talk about the topic of the day, and I've asked about the topic. I hope you understand. If you didn't go through this, we talked about it yesterday, about the genotype, and how your DNA brings you to be who you are, how you pass. Yesterday, if you have not gone through the topic of the day yesterday, go through it. How you are looking, resembling your father or your mother. I talked about it, about these strands, how they make you resemble, because the assembly of this is what makes your DNA. The assembly of this that comes and forms this thing called an allele, chromosome, is what is inside here, and it is what is making a DNA. So you go through it, you will be enlightened. If you are not here yesterday, but if you are here today, you are free to ask any question, anything that you feel like you are not understanding. Very nice. Now, what do you think about breast cancer? Is it a disease of men alone, women alone, or it can affect even men? It is very important to understand these things. Now, let's talk of breast cancer. we're starting a topic that is very important. Boss One, welcome. Thanks a lot for your blessings, man. I can see you are here. You are here, and you are always you are always here, and we thank you for your support and everything. Jay Kingre is here. Jamaican uncle, today you are the first. I can see Maureen Kawila, Bibi Shosh. I can see Herbs and Spice. Welcome. I think Herbs and Spice was the first one to say, Doc, talk about breast cancer. Live Love TV is in the house. Welcome, Live Love TV. Everyone, Miss Marie, okay, all of you that are here. Today is the day that women are so welcomed, because people think that breast cancer is only for women. Now, breast cancer involves a series of genetic, molecular, and structural changes that transform normal breast into malignant ones. Normal breast cells into malignant ones. Now, malignant means it is spreading. The cell that is mutated is causing the others to be affected. So it is spreading and going through. You see, normal breast structure, breast tissue is primarily composed of ductal epithelial cells, breast cancer, breast cell, the normal cell, your normal breast has ductal epithelial cells, lobular cells which produce milk. Those milk producing cells are called lobular cells. Myoepithelial cells help expel milk from the muscle, that's why every time you hear myo, no, it's a muscle that helps. Today is the second sister birthday to Boss One. What's up, my people? Jankwan in the house. Welcome, Jankwan. And then we have we've talked of lobular epithelial cells. So your breast has ductal epithelial cell line the milk ducts. The milk duct. I love drawing, but drawing is good because it helps people understand. Stromal cells. I'm drawing something here so that I can explain. I can explain well and better. Now, look here. A breast look like this. So the nipple is here. And we have ductal epithelial cells they line the milk duct here, inside here. Epithelial cells, they line anytime you hear epi, know that it is outside, so they line the milk ducts. Lobular epithelial cells produce milk in the lobules. Lobular epithelial cells, they produce milk. Modular epithelial cells. Myoepithelial cells are muscles. They are straight like this. They help push milk out. And stromal cells include connective tissue. So you will find some tissues here that are fats. So fats filled like and blood vessels that are inside, they are called stromal cells. Now, in healthy tissue, these cells divide in a controlled. So the cells that I've named, the ductal epithelial cells, lobular cells, myoepithelial cells, and stromal cells, there is a way they divide in controlled manner. And you know, there are some factors that when your cell has lived for so long, there are some factors that arise and they kill the cell that have lived so long, so that it cannot continue growing and mutating. So most the life of a cell mostly lies between 100 to 120 days of one cell. And you see, the breast has how many cells? 1, 2, 3, 4. Ductal epithelial cell, lobular epithelial cell, myoepithelial cell, and stromal cell. Now, breast cancer begins when mutation occurs in the DNA of breast epithelial cells. These mutations, breast epithelial cells, I said, wait. Epithelial cells, outermost. In your breast, the epithelial cell, I don't know if I can share this image, let me see. Lobes, lumen, brain. See, I want to find a way so I can share this image. Let me see if I can do it, so that let's learn slowly. If you have a question, my guys, if you have a question, just ask any question. We see how we can interact and help each other. Interact and help each other. Okay, I can see I have not used the app, so I will use this. The epithelial cells line around this area, and epi means epithelial cells mean outermost. And you see, we have said epithelial cells produce milk in the lobules, and as per our my first statement, we say breast cancer begins when mutation occurs in the DNA of the breast epithelial cells. This mutation disrupts normal cell regulatory and triggers uncontrolled growth. Epithelial cells, they are cells in your breast that produce the milk. So there is some things I want you to understand, that there are factors that when you have them, you are healthy. And there are factors when you have them again, you have a problem. So there is something called BRCA1 and BRCA2 that control DNA repair. Today I'm going so slow and calm so that someone may ask a question concerning breast. I want everyone to understand what is breast cancer. You see, there is something called BRCA1 and BRCA2. They help when your DNA, you see, when your DNA is disrupted, maybe you are smoking and then one gene is disrupted, they help repair this genetic makeup. It is called breast cancer gene 1. You get it? Is a crucial tumor suppressor gene that helps protect the body from cancer. Mutation in this gene significantly increase the risk of developing breast and ovarian cancers, among others. So breast cancer gene 1, I'll put it there, BRCA, breast cancer, it's good. So every woman, every person, every man has this thing called breast cancer gene 1. Breast cancer gene 1. It repairs the DNA, because we have seen cancer starts from the epithelial cell. So when this strand is destroyed, you are smoking, you are taking things that have free radicals that are replacing these strands of the chromosome, in the nucleus, breast cancer gene 1 comes and repairs them to become normal so that you cannot continue mutation, because mutation leads to cancer. You get? And then we have breast cancer gene 2. Breast cancer gene 2. Breast cancer gene 2 is a tumor suppressor gene that plays a key role in protecting cancerous cells. It is in your body. It walks around checking. Is there any cell that is mutated? Is there any cell that is in this body? That one I'm posting there. If you want to read about it, you can read. It goes around your body looking at, is there any cell that is a cancer? Is there any cell that is a tumor? And then it destroys, it suppresses gene that plays a key role in protecting cells from becoming cancerous. You see, now mutation in this gene increase the risk of breast cancer. You see, because it is helping you to destroy the genes that, so we have talked about breast cancer gene 1, which helps to, remember to like, very important, which maintains your gene at the breast level, because your breast is made up of genetic makeup at the cells. So that is breast cancer gene 1. And gene 2, breast cancer gene 2, that I've posted there, it is a vital tumor suppressor gene. It stops any cells that can bring cancer. When I'm talking about tumor, I'm talking about cancer. Those are the two important things that you need to know. Breast cancer gene 1 and breast cancer gene 2. Breast cancer gene 1 and breast cancer gene 2, they help you so that the cells at your body, the cells at your cellular level cannot mutate, cannot start. You see, sometimes you do things that affect your body. Smoking, drinking alcohol, eating foods that are introducing things like free radicals. Free radicals, what they do? They destroy the DNA. So cancer gene 1 repairs the DNA to come back to normal. Gene 2 suppresses tumors. It suppresses cancers. So your breast is always on watch out. And these are they are the watchdogs of your breast. So we continue. We have another one. Which is TP53. Allows damaged cells to control cell cycle and apoptosis. So TP53, we have 53, we have 54. What is TP53? We want to learn things that help you not to get cancer first, and then we see how they are affected. TP53. It is one of the most important genes in cancer biology. Often called the guardian of the genome. It plays a role in preventing development of tumors, maintaining the DNA integrity. So TP53, this one maintains your DNA to be what it is. Now we are talking about the breast, the DNA at the breast level, and we have seen where does cancer starts from. It starts from the epithelial cells. Epi means outer. So outer, and most of the epithelial cells, what do? According to our previous topic, they secrete. Secrete is they remove some products, like in the breast they remove some milk. They secrete milk. So the breast cancer gene 1 and breast cancer gene 2 plus TP53, they maintain the integrity of genetic makeup of your breast. so that the chromosome at the cellular level inside the nucleus cannot be interchanged to start doing some things that they are not supposed to do. Whatever that I've written, see, this strand is here, and this strand is the one which makes what? The gene. And after the gene, you have that DNA inside that gene. Now, TP53 produces the integrity. It makes the DNA at the breast level, let me say at the epithelial levels where most of the cancer starts from, of the breast, to be what they are supposed to be. We still have, that is TP53. Let me post TP53. If you want to follow up, I'm posting them at the chat so that you can look upon them. We have something else called HER2, ERBB, causes excessive cell proliferation. HER2, HER2. Let's see what HER2 does. We are still maintaining the proliferation and the integrity. And now HER2, what does HER2 do? Because HER2 is another factor that you have. Yes, come in. Mzee amemalizia. Watakuja tu hapa wasimame kule. Nani? Vincent na mzee. Mzee akae hapa, Vincent pale, talk to them. Wakuje sahi, sijaenda sana. HER2, what I've texted there is called, if you are coming in, remember to like, is a gene that plays a critical role in the growth and development of cancer. It is a gene that plays a critical role in the growth and development of cancer. You get it? Yes, welcome, Rogers, I can see you. Particularly breast cancer. Unlike tumor suppressors, genes such as BRCA1 and BRCA2 and TP3, HER2 is an oncogene, meaning it is overactive, promotes and controls cell growth. Now, HER2, that one is the one which brings cancer. You get? There are some people who have this factor a lot. Human epidermal growth factor receptor 2. It is called human epidermal growth factor receptor 2. And this one is the bad character when it comes to, this one is the bad character when it comes to what? This one is the bad character when it comes to, this one is the bad character when it comes to now breast cancer. You understand, everyone? If you have a question, I'm going so slowly so that anyone can understand. These are the factors that are so important when it comes to breast cancer. We have said the first one was breast BRCA1, BRCA2, TP3, TP53. You remember them? TP53, and these ones are the ones which protect the cell. You get? TP53 mutations and cancer lead to production of defective TP53 protein, allowing cell division and unchecked proliferation. So if you have low TP53 in your body, you will have more proliferation. The HER2, human receptor epithelial cell factor. And you see, remember we have talked about where the cancer starts. Where cancer starts from? The receptor itself, epithelial cells. But here we have another gene that is called HER2, human epithelial cell receptor, which helps these epithelial cells to live long and proliferate more. So it is not a good thing. It is not a good thing. Let's see. There are several things that we need. So the ones that we have said are good are BRCA1 and BRCA2 plus TP53. You see, plus TP53. So BRCA1, which is breast. I hope everyone is following and listening politely and so nice. Am I being clear or am I being complicated? I think I'm explaining those things. So like breast cancer gene, it's a gene in your body that helps to destroy the tumors that are in your body. Now there is breast cancer gene 1 which repairs, and there is TP53 which makes the integrity of the breast be what the gene of the breast of the epithelial cells be what they are. But we have another one which is called the HER2 and HER1, human epithelial receptor gene, epidermal growth factor. It makes sure those cells are growing so much. We still have some others regulate cell growth. Effect of mutation. You see, if it is mutated, you will make it Albanian. Edit is here Albanian, and you can ask anything in the middle of the talk. Now we have PIK3CA. We have PIK3CA. PIK3CA is a very important factor again. So if you have a question concerning the talk, it is important you just ask. Don't be confused on the talk. This is a talk. Don't be confused. We are talking about breast cancer, and breast cancer, we have said, starts from the epithelial cells, and the epithelial cells are the ones which do what? Help to remove milk from the mammary glands. Now, the one that PIK3CA, these are factors, they are genes. I've started with these genes so that you can understand. Is an important oncogene frequently mutated in human cancer, especially breast cancer. It plays a role in regulating cell growth. So we have PIK3 and we have human epidermal growth factor receptor. Those ones, they deal with regulation of the cell, the epithelial cell growth. You get? So we have PIK3 for it deals with metabolism and signaling pathway. Signaling pathway is when you want to crush some others and you want to proliferate to come up with some new ones. You get? The question, yes, coming. The question lies, I'm still asking if you're coming in right now. Do you think breast cancer is for women alone or breast cancer is for other people? Okay. It is too long, eh? Yes. It is.
particular person.
Yes.
These are the please and I repeat please.
Yes.
Let's address one confidence.
Confidence, guys. Just a minute. I'm dealing with an issue. I'll be back.
One is responsible for whatever.
Sorry about that commercial break, Marcia. I can see you're here, and sorry about that. You've relaxed a bit, and I can see that I'm not hearing. It's only me. Is it only me? No, Marcia, I had put the microphone off. I was advising a client, so it couldn't be. You understand? Ethics. I think right now everyone is hearing me. Am I loud and clear? Am I loud and hope everyone is listening? Okay, I'm hearing now. Welcome. Now, as we continue now, we have some factors. Breast cancer. The breast cancer itself starts from the epithelial cells. And the epithelial cells are the cells that produce milk for the baby to suck. And we saw when we started talking about cells, epithelial cells are the cells. I see Betty's World has come. Welcome. The epithelial cells are the cells that secrete milk. They secrete. They are used for secretion. So we will talk about the epithelial cells, and then we will talk about some factors in your body, that maintain you not to have a problem with mutated cells at the epithelial layer. So we have breast BRCA1. We talked about BRCA1. You remember breast cancer gene 1, breast cancer gene 1 and gene 2. Gene 1 repairs the DNAs. When they are walking and then they see this DNA has been destroyed, it helps to repair so that it cannot start mutating to be something else. Gene 2 does what? Destroys and helps in the bad ones that have been destroyed. You get it? Leads to, when it is affected, you can lead to instability and decreased risk of cancer. If you don't have BRCA1 and BRCA2, it can lead to genomic instability. Genomic instability means your genes at the epithelial layer are destroyed. There is nothing that is controlling them. There is nothing that is controlling even the proliferation. Now we have something called the PICA3CA, which we have talked about, and we have said is an important oncogene frequently mutated in human cancer, especially breast cancer. It plays a role in regulating cell growth, metabolism, survival through pathway signaling. Which cell should die, which one cell should be produced, which one is still okay. Those ones are called pathways. You get it? Very important. That is very important when it comes to proliferation. Now we have some breast cells that are, we have all breast cells, but the most important cells of your breast are the most important cells of your body are the epithelial, at the breast are the epithelial cells. We have something called MYC, regulate cell division. MYC, regulate cell division. You know, there is a way cells can divide. There is a way. Efasi and everyone watching is here. Efasi, greetings, Roger Killer. Efasi, today we are talking about breast cancer, and I'm going, so hope my slowness today is not making someone bored. My slowness today is not making anyone bored. Because I want everyone to understand where breast cancer comes from. MYC is a powerful oncogene that plays a role in regulating cell growth, proliferation, metabolism, and apoptosis. So MYC, it determines which cell should die, and it determines proliferation. Onik24, welcome Onik. Today we are talking about breast cancer, and my question was, do you think breast cancer affects only women, or it can affect only men? So let me go through those factors that I've named. The BRC, breast cancer gene 1 and breast cancer gene 2. Their function is DNA repair. They repair the DNA at the breast level. If your gene, you have been smoking, you have taken foods that have a lot of free radicals and they are destroying the gene BRCA1, breast cancer gene 1 and breast cancer gene 2. They repair your actions, they repair the DNA at the epithelial site so that you cannot get gene cancer. But if they are not there or low, or they have been destroyed, you can get instability in genomic marker. Increased cancer comes here. TP53, what is the work? Control cell cycle and apoptosis. Cell cycle meaning it controls how a cell dies, when it will die. If a cell lives for so long, it can get a mutation. You get? So it controls that process, allows damaged cells to survive. It allows damaged cells to survive. If TP53 is low, or it has been destroyed in your body, or you in your family were born with problems with this TP53, you know what? The damaged cells will survive, and the damaged cells are the mutated ones. So you can get cancer, because damaged cells means there is somewhere at the gene level that they are not okay. Human epithelial cell receptor. Human. What about this cell? This human epidermal growth factor receptor. What if you don't have it? What will happen? Human epidermal growth factor receptor causes excessive cell proliferation. So if you don't have that is well in your body, what will happen? You will damage your cells, because they will glow without. That is when you see the cancer that is coming so much, because is persistent. It's not there. It's not there. So there is nothing to control the production of cells. PICA3CL promotes uncontrolled growth if you don't have it. Those are the things that we should look at. They are the genes. Now, when we talk about genetic makeup, these are the things that mostly, when you check at a family level, some people are always having problems with they're always having problems with cancer, breast cancer. You will find maybe they have one of these is not there, or is at minimal level, so there is nothing to control. These are the markups that are very important when it comes to breast cancer. Are we together, or is anyone understanding what? I'm giving you some factors that help you not to get breast cancer. So cellular changes in the breast. When I'm saying cellular changes, I mean the cell have transformed, and now we are coming up with something that is cancer. Cellular changes. At the cellular level, cancer cell exhibits distinct abnormalities. Some abnormalities that the normal cell does not have. But you've seen we have some factors that maintain the stability of a cell, those genes that I've named. And the stability of a cell comes at the nucleus of that cell, the epithelial cell itself. The strand that is supposed to be genetic like this, those factors maintain that strand to be like that. Hi, Dr. Ben. Hi, sister. You're here. Oh, I've seen you. You've just been on your live and you're growing so fast. Thanks for that growth. I want you to grow so fast, sis. Grow so fast. Continue with that spirit. Margaret in Norway. Welcome, welcome. So, you have seen some factors, and I repeat, in some families that there is a family which just have a problem with breast cancer. Maybe these factors, one of them is not there. And so we will know how to maintain and how this person can live. But for now, what are the abnormalities that are exhibited, that are shown at the cellular level? When I'm saying at the cellular level, I mean at the breast epithelial cells, because that is where we have seen cancer starts from. So one is uncontrolled cell proliferation, loss of regulation in cell cycle, and increased mitotic activity. They differentiate every time. Maybe our growth factor that is called the one that increases proliferation has human epithelial receptor cell is proliferating every time. Is always is low. So your cells are just proliferating anytime. Maybe in your family that gene is low. That's why that is the first factor. The first factor when you look at proliferation, cells are multiplying so fast and they are uncontrollably multiplying. Loss of regulation in cell cycle. So your human epidermal growth factor receptor, the gene itself, maybe in your family it's low and you don't know, and you take things that activate the process. Eating junk food, smoking, taking alcohol, and they increase because there is nothing that can tame them. Maybe the factor is low. What happens? It increases mitotic activity. Mitotic activity means division. Mitotic activity means division. A cell wants to produce another one, so it produces uncontrollably. Loss of differentiation. It is called anaplasia. Cells lose their specialized function. So you see, these cells lose their specialized function in this way. At the cellular level, at the epithelial level. Aristopath, welcome to the chat. If you have any question, ask. Please make sure you like the chat. If you are a new person, interact with people at the chat. Don't just watch, interact with the people. There are good people at the chat. We help each other. So like, and let's follow up. Now, we have said a very important thing, loss of differentiation. It is called anaplasia. When the cells are multiplying so fast and becoming so many, what happens? They lose their function, appearing irregular and primitive. In this way, their function, like the epithelial. Alice Mwangi is here. Alice Mwangi is here. Is calling someone Wem Kenya. Okay, who is Wem Kenya? Wem Kenya, come. Alice Mwangi is talking. We are talking about breast cancer. We are talking about breast cancer. So loss of differentiation means if at the epithelial level it is used to produce milk, you get, because you have seen epithelial cells is where the cancer starts from. So because it is supposed to produce milk, and now at the genetic level it has mutated, what happens? It starts to do something else. It stops producing, the mammary glands stops to produce milk, they start to produce something else, maybe blood or pus or secretions that are not milk. And you've seen most of the cancer cells, they bleed a lot. What are the chances of men getting breast cancer? Yes, Aristopath has asked a question, what are the chances of men getting breast cancer? What do you think? The answer is in the topic. Let's just continue and listen. Now, these are characteristics of cells that differentiate the characteristics of cancer. I'm going through characteristics of cancer at the cell level, because you have seen cancer starts from the cell. So the cell that cancer starts from at your breast level is at the epithelial cells. Epithelial cells are secretory cells. They secrete milk at the breast. You get? So here we're talking about uncontrolled cell proliferation, which means loss of regulatory in cell cycle, increased mitotic. Mitotic is division, multiplying, a cell producing another one. Loss of differentiation. Loss of cell differentiation means a cell doing a specialized work, a cell doing a specialization. Like if it is the skin, the cells of the skin, their work is the specialized work is respiration and protecting the body. That is differentiated to that. It is differentiated. But you will see that the differentiatory state of epithelial cells at the breast level is to produce and secrete milk. You get? So here at the cancer, when they are not differentiated because of mutation, maybe because of distraction, they start doing something else. Okay, C, nuclear abnormalities. Nuclear abnormalities means cells at the nuclear level. Cells at the nuclear level. Enlarged nuclear. The nuclear level at the cell is enlarged. It's enlarged. And you know, when the nucleus is enlarged, it means more chromosomes and more things that are not normal. Increased nuclei to cytoplasm ratio. That means this one, cytoplasm ratio inside is increased. And nucleus is Alice Mwangi. Yes, I'm a Kenyan. Alice Mwangi is asking if I'm a Kenyan. Yes, I'm a Kenyan. Hope you are happy about that. If you have any question concerning any medical thing, this is where you can ask Alice Mwangi. This is where we can talk. If you have any issue, you can interact with people at the chat, and we can see how we can help. Today the topic is we have started a week of cancer, and it was a request from the people that we start with breast cancer. So today, instead of going the normal way, because cancer has different types, we have tumors, we have carcinomas, we have benign. I decided we do breast cancer, and then maybe at 10 or tomorrow we will do the different types of cancer. Now we nuclear abnormalities, there is something called increased nuclear to cytoplasmic ratio, which is very important. Your nuclear to cytoplasm ratio is important. We will see as we continue. So if you have any question, don't be ashamed to ask. Just please question and we see what we can do. Loss of contact inhibition. Cell pile up instead of forming organic layers. Now these are the characteristics of cells that are mutated. And you see, it means they have mutated because the problems that we talked about, you remember the genes that I've just talked about cancer, the BRCA1, breast, BRCA1 and BRCA2, TP53, human epithelial receptor 2 has 2, PICA3CA, those ones have gone through, and MYC. Maybe you don't have them, or your family genetically are born with a problem of these genes. This is where you get some problems. And I will repeat about it as I finish the characteristic. Human epidermal growth factor receptors are very important. You get? So these are, I'm just naming some of the characteristics of cancer cells. There is a version of apoptosis. Cancer cells, especially the cells of your breast, when it comes to cell death, because after they have lived for some time, they have to die so that the new cells that are differentiated I've said, that can perform the function that are supposed to be performed, they come out. They don't die. They know how to evade the factors that kill them. There are some factors that kill. Like in the liver, we have P54 that kills cells that have lived for so long. Here, these cells, they evade that process, so they don't die. They continue living because they are mutated and they are doing the wrong thing. And then we have something called angiogenesis. Tumor stimulates new blood vessels formation, because now this cell, the epithelial cell, have mutated and is doing something else. It starts to form some new blood vessels. Now it's not the epithelial cell that we know. It starts to form something else that is not the epithelial cell. Via something called vascular endothelial growth factor to obtain nutrients and oxygen. So when the cell mutates, there is something called vascular endothelial growth factor, VEGF. We call it VEGF. It starts to create it, and then because cancer cells need oxygen and they need nutrients, they start to form the VEGF. The VEGF help them. They form vasculars like blood vessels, capillaries, so that they can get oxygen and nutrients. And then there is inversion and metastasis. Cancer cells break through the basement membrane, spread through blood and lymphatic system to distant organs. They know how to spread. You get? So these ones are important. Anyone with a question? We are going slow. Has anyone understood the topic of the day? Breast cancer? Has anyone understood, or we are listening clearly and going so politely? Because understanding is important. This topic of cancer will not end today. I want people to understand first the things that help you not to get cancer of the breast. So the first thing we have talked about is it starts from epithelial cells. The epithelial cells are the first the first places, and the epithelial cells of your breast, where is that? This one. That produce, they are called epithelial. Your breast is like this. So you will see these lines that are here that contain those cells. That produce milk. Because when we talked about cells, we were talking about something that is called epithelial cells secrete. They are involved in secretion. So in your stomach you have epithelial cells, in your mammary gland you have epithelial cells, and those epithelial cells are the ones which secrete milk when you are breastfeeding. You get? So breast cancer begins when there is a mutation in the DNA. I'm going slowly today. When there is a mutation in the DNA of the epithelial cell. So let's get to here. This is your breast. These are the epithelial cells that are lined. And this one is your list. And this one is your cytonucleus. Inside we have the chromosome. The X thing is the chromosome. And then we have the strand of the DNA here. The strand of the DNA. So this strand of the DNA, is the one which, if it is interfered with, your cell will never be the same again. Your cell starts to do things that are not meant. It is not meant to do. So we have human epidermal growth factor receptor gene. So we have some genes. Can prolonged fasting kill cancer cells? No. Prolonged fasting will kill you more faster, because if they need energy and you are having cancer cells and you yourself you are fasting, they will destroy your body. Faster. So herbs and spice, prolonged fasting cannot kill cancer cells. It will destroy your body. So there is some genes. There are some genes that are involved. Things that help you in your body to make these cancer cells stay away from the body. To make the cell integrity be the same. To make that breast cell the way it is supposed. You see, this Pami Diary is so informative, Doc. Thanks, welcome. Thanks and welcome so much. Welcome to the channel Pami Diaries. Today we are talking about breast cancer, and everyone in the group, if you are here, if you are new, don't forget to subscribe. It is important, and so that you can get updates, and also watch and share. This information can help someone. So genes, these genes we have talked about, we have some genes like breast cancer gene 1 and breast cancer gene 2. So gene 1, we have said it repairs. Gene 1 repairs. You see this gene, breast cancer gene 1, if this gene has been destroyed, and how can it be destroyed? We saw yesterday what can make you get breast cancer. Smoking, eating foods that are containing free radicals. What free radicals do, they only displace these proteins, these nucleosides. They only replace. So if cytosine is replaced, something comes there. Then this genetic makeup is not the same. It is something else. You get? It means this genetic makeup is not now the epithelial cell. It will come up with something else. So BRCA1 gene 1, breast cancer gene 1, and breast cancer gene 2. What they do, I'm repeating so that we can understand well, leads to genomic instability and increased cancer risk. Because if there is nothing to repair your gene at the breast level, what will happen? If there is nothing to repair, then it will continue mutating. So we have TP53. TP53. What is TP53? It is a gene inside your body that helps TP53. It is your gene inside your body that helps to look around your breast which cell is living long and which cell is not doing the right thing. This one is the one which takes that cell. Wait a minute. It takes that gene, destroys it. It causes a process called apoptosis. Apoptosis means cell death. Cell death. And that's why it was named, and that's why this gene was named tumor protein 53. Tumor protein 53. Everyone has these things, and that's why your mammary glands integrity and your breast integrity is the way you are. You see, we have something that is called a very important thing that is called HER2, which regulates cell growth. Your cells should not just grow. Your human epidermal growth factor receptor. Human epidermal growth factor receptor. It controls how cells proliferate. You see, the cell growth, because if they are not controlled, they will grow anyhow and they'll start to mutate. So without this one, you are prone to cells that are proliferating and growing without even being, you understand. This I'm going through this so that when we are discussing how the breast cancer itself multiply, you understand why is these family members having always breast cancers. Why is it that in my family we don't have breast cancer, but I got breast cancer? That's why today I'm very slow and repeating this. And if you have a question concerning these guardians of the cells like P53, TP53, ask. PICA3CA is called phosphatidylinositol 4-biphosphate kinase catalase subunit, a very long one. And you've seen what it does to our bodies, promotes cell signaling and survival. This is the one which controls how a cell should live, which period it should live, and should it go beyond, or is it doing the same work that it's supposed to be doing? It checks if that cell is doing what it's supposed to be doing. So if it is not doing what it's supposed to be doing, what happens? It signals the HER, epithelial growth, and BRCA1, so that it can be destroyed. The cell that is there can be destroyed. Okay, Pamidar is watching. I choose quiet, simple life. I see. That is Johnny Be Good. And then we have my MYCA. These things that I'm naming, Tulips Cobra. Hello, doctor, and everyone in the room. Tulips, welcome. We are talking about breast cancer, and today I'm giving important message about what helps you not to get breast cancer, very slowly, and teaching the people very slowly. You understand? Myelocytomatosis oncogene. Myelocytomatosis oncogene, MYC. This one is the one which controls how many cells should be produced, how many cells should live. It regulates cells division, multiplication of cells. Without it, if you have cancer, it will spread so fast. Even if you have no cancer, your cells will not be regulated. They will be multiplying. You get? Going so slowly and understanding these factors slowly by slowly. The first thing we have talked today and we have said is cancer of the breast starts from the cells that do what? The cells that multiply, the cells that produce milk, epithelial cells, because they are the cells that are called secretory cells. That is the first factor. And then the other thing we have said is, in your body, there are those things, genes, that if you don't have enough, or if they have a problem, you will have a problem. I can see Gabriel. Wow, good evening, Benjamin, and hello, everyone. You will have a problem when it comes to proliferation and supportive nature of your breast. So these things are, I repeat, you check and see BRCA1 and BRCA2. We have said what these cells do, BRCA1 and BRCA2, breast cancer gene 1 and breast cancer gene 2. We have seen about TP53, tumor protein 53. We have seen what it does. We call it HER. And you know why we call it HER? It is called human epidermal growth factor receptor. Human epidermal growth factor receptor. Then we have PICA3CA and MYC. Those are the genes that control your body. And when you are smoking, taking alcohol, you are destroying these 1, 2, 3, 4, 5 things. And when you are destroying these 5 things, that is where the problem now starts. Because your cell starts to evade apoptosis, they start to evade cell death, they start to evade differentiation. I've said differentiation is a cell taking, skin cell cannot do the work of epithelial cell in the mammary glands. The epithelial cell in the mammary gland cannot do the work of an epithelial cell in your stomach. Stan's Kitchen, hi, welcome. You see? So they are differentiated. That's why we say cell differentiation. Cell differentiation means these cells doing specific job, you see, and it is the work of what those genes that I've named to do whatever they differentiate, and those genes take care. There is those you've seen that surround your body, around your gene. If they see there is a problem, they kill that cell. It's programmed cell death. Programmed cell death means when the time of a cell has come to die, it dies or killed. You get? If it comes a time of a cell to be produced or under specialized mechanism to become an epithelial cell, it is differentiated and it is specialized to produce breast milk. You get? So those are the genes that are very important in human body. And then we have said, listen to this, we have said another thing which is very important. Cellular changes in breast cancer are seen in these points: uncontrolled cell proliferation, loss of proliferation means uncontrolled regulation in cell growth, in cell differentiation, in cell multiplication. And there is loss of differentiation, that is the second thing, anaplasia. A cell is not doing what it's supposed to be doing. This is now cellular changes in breast cancer. Nuclear abnormality. You start a cell which is big with a big nucleus. It's not even doing the work it's supposed to be doing. You get? Loss of contact inhibition. Cells pile up instead of forming organized layer. They just pile up instead of forming organized layers. You know, there is a way cells must be organized. So they don't, because they are irregular, they are mutated, they start to pile up. And remember, it's at the breast level. And then they start knowing how to evade mutation. They start knowing how to evade mutation. They are apoptosis, They start knowing how to evade apoptosis. Apoptosis is programmed cell death. They start knowing how when TP53 comes to kill them, they know how to evade P53 so that they cannot die. So they live long. Angiogenesis. These are now mutated cells. They have to get nutrition and oxygen. What do? They start forming other blood vessels like small capillaries very fast. There is something called vascular endothelial growth factor. They help these cells to grow some capillaries and some vessels so that they can get more oxygen and nutrients. And remember, I said cancer cells like glucose. They need more glucose to survive because they are proliferating so fast. And you've seen there is one of us who was asked about does fasting cause welcome Betty's World, does fasting cause the cancer cells to die? I think all cells do the same work, Dr. Benjamin. No. Uncle Don cells, all cells does not do the same work. You see, cells of your skin are not like cells of your mouth. Cells of your tongue are not like cells that are in your eyes. They do different things. Your tongue do something else. In your stomach lining, there are cells that are epithelial cells. They secrete some enzymes like hydrochloric acid, some fluid. So they don't, cells of your air. Yes, sorry about it. There was a mishap in someone messed up the power line, but we are still here. Thanks everyone who has waited. Thanks everyone who has waited. So we were talking about breast cancer, and we have seen those are the factors that are coming through when it comes to cell. So the first thing you need to know in a setup of we still have some time, in a setup whereby a person has a problem when it comes to cancer. I will put down some notes about before I will continue tomorrow, but today we have seen some factors that can activate or can lead a person to have a problem when it comes to breast cancer. The first point you need to understand is any problem with the genetics, the genes that we have talked about. Any problem with the genes that we have talked about, the HERS, the TP53, you get all those. Any problems with those can bring a very big problem. And in breast cancer, the most important thing is those 5 genes that I've talked about. The 5 genes that I've talked about are the ones that make a person to have breast cancer. Breast cancer 1, breast CA1, breast cancer CA2, TP53, HERS, human epidermal growth factor 2, there is something that is called PICA3CA and MYC. Those are, when you hear someone has breast cancer, the first thing you need to think of are these three genes. 1, 2, 3, 4, 5. The 5 genes, they are the ones when one has a problem, you will start having uncontrolled cell proliferation, loss of differentiation, nuclear abnormalities, loss of contact inhibition, eversion of apoptosis. Apoptosis is cell death. Angiogenesis, you start your breast starts to form. If you have ever seen someone with breast cancer, you will always see where the cancer is, there is a lot of blood, and it seems like an organ that is forming with some veins and capillaries. It is because it is forming. The tumor stimulates new blood vessels. The cell that has mutated starts to stimulate some blood vessels. It needs to grow. You see, very important information. And as they grow and form most other cells, what do? They start to know how to evade apoptosis, cell death. It is important to note these things. Now, power issue, but I'm back. Now, that point to there, it is very important to understand. And I see, if you have understood about proliferation and the breast cancer itself and how it comes, now you know, maybe when you are asked about family issues, why is it in this family there are cases of breast cancer? Think about those genes that I've talked about. Maybe they are born with less of the genes, or no, they are born with no factor at all of the 5 genes. So cells proliferate and they differentiate anyhow when they are being produced. See, so classically, we have seen the importance of. Now we will continue with the types of molecular subtypes of breast cancer. We have there are several subtypes of breast cancer. We have something called luminal A, we have something called luminal B, we have something called HER, human epidermal receptor growth factor 2 enriched. We have triple negative. We will learn tomorrow how these cells, how these submolecular come out. You get? So tomorrow you'll be ready to learn about the types of cancers that come. These are identified based on receptor expressions at the cellular level. The subtypes of cancer, the types of breast cancer that come out, how do they come? Get? So we have as we continue, we will learn something called the histoprogression. Histoprogression, breast cancer develops in stages at the cellular level. The cell, it progresses in stages. Normal epithelium, hyperplasia, increased cell number, atypical hyperplasia, abnormal cell appearance, carcinoma in situ, that is ductal carcinoma at the site, lobular carcinoma at the site, invasive carcinoma, you get it, spreads. We will learn about all these things. Metastatic cancer, there are some cancers, breast cancer that don't spread, but why does this one spread? Hallmark of cancer in breast tumors. We will learn how they spread. Now, if you are continuing, we are just about to finish, and if anyone has a question, please put out that question. There is a question, there is this question that tomorrow we learn about subtypes of breast cancer. Today we have learned the genome that help you to protect your breasts. So today, if there is a family that they are suffering from breast cancers, those subtypes genomes, the genes that I've said, and maybe one of them they are born with that problem. So there is a question that has been asked: why women suffer most of breast cancer? Why women suffer most of breast cancer? Why? There are some things that I want us to understand about women, and it's important that you know that women are, let's say, hormonally, in their hormones, their hormones change every time. They have more hormones that make them change their ways of things every time. You get it? So women suffer most from breast cancer mainly because of biological, hormonal, and genetic reasons. Related to how female breasts develop and function. Breast cancer anyone can suffer breast cancer. You see, anyone can suffer breast cancer, but women are the most affected. Okay, let's see. That's what's happening to my daughter, mother-in-law, right now. It reaches the stage that they take her off medication and only give her pain medication right now because it cannot help anymore. Yes, there is that is called palliative management. You see, when it comes to management, the staging of the cancer has proliferated. So it will not be the same like, let's say, if you give drugs, you are making this person to suffer most. If you give drugs, you are making this person to suffer most. So the only thing you can do is palliative management and wait to see the next day. So I will give some factors that are important. Why? This is Johnny Be Good has given us flags from Kenya, Canada, and Jamaica. Massive respect, Johnny Be Good, for those flowers. Thank you so much. Now, women suffer most from breast cancer mainly because of biological, hormonal, and genetic reasons related to how the female breast develop and function. Check. Most breast tissues and hormones are very sensitive. Women naturally have much more developed breasts than men because they have lobules and ducts. Men don't have lobules and ducts. And so women have more epithelial tissues at the breast. You get? These tissues is highly sensitive to hormones, especially estrogen and progesterone. And you know, women have high progesterone levels. You understand that? Women have more progesterone levels. These hormones stimulate the breast cell growth. These hormones stimulate the breast cell growth. The more a tissue grows and divides, the higher the chances of DNA mutation. So if a tissue grows so fast, and women have more estrogen, you understand, it can have a problem when it comes to developing cancer. Faster growth means it can start proliferating to something that is not supposed to be, which is cancer development. You get? Which is cancer development. So the other thing that why women get breast cancer more than men, this is a question. If you have a question, anyone, you can raise it up. If you have a question, you can raise it up. Lifetime exposure to estrogen. You remember when we're talking about estrogen and family planning, women are exposed to estrogen for much longer time due to early puberty, monthly menstrual period because of the cycles, pregnancy, sometimes hormone therapies or contraceptives. They make women susceptible to estrogen. You see, long exposure, more repeated stimulation of breast cells, higher mutation risk. Genetic susceptibility, close to. Susceptibility means prone to, or you can get. You get some inherited genes mutation greatly increase risk, especially breast receptor CA1, BRCA1. And we have seen because if you don't have something that is taking care of your breast integrity, maybe in your family, you have, when you are born, you have a mutation of BRCA1 and BRCA2. Your cells, when they are exposed to dangers, there is nothing to repair them, the epithelial cells of the breast. Now we are talking about the mutation of the breast. This gene normally help repair damaged DNA, the BRCA1 and BRCA2. So any damage to these genes, and you know, when we talk about breast cancer, most of the cases that of breast cancer, comes from the problems with these two genes, BRCA1 and BRCA2. This is where the problems come from. You get? So develop genetic susceptibility means in your family line, you are born with the problem of this gene in your bloodline. When you are born, maybe it is less, or sometimes you don't have. Breast cancer is linked to female reproduction biology. Breast tissue is designed to prepare for breastfeeding. Because of this, it responds strongly to reproductive hormones, undergoes frequent changes across woman's life. Every time hormones change, puberty, pregnancy, menopause, you get estrogen, progesterone, always changing. More biological cycles than a man. Age and accumulated risk. Age also, because most of the time you will find that age is a problem, because age and accumulated risk. Age and accumulated risk. As women get older, DNA damage accumulates, because you see some women taking junk foods, some women taking foods that they are not supposed to take, cigarette, alcohol. So as you get older, the DNA is damaged. And when your DNA is damaged, what happens? That is the first step of epithelial cells in your breast mutation. And repair cells sometimes become inefficient. Sometimes the repairing, the way the cells repair themselves, the BRCA1, when you get old, that gene factor has no strength at all. So what happens? Mutation causes cancer. Hormonal exposure continues over decades. You've been having those hormones for decades. And there is something called hormonal replacement therapy that we do to women. Exposure to some hormones like estrogen. They may really cause genetic problems, and they may bring problems to cancer. Yes, so that is of today as we continue with breast cancer. All that are still online, if you are new, don't forget to like and subscribe. That is always what I tell people. Don't forget to like and subscribe. And you have noticed the topic of the day, we have talked about 4 important things. The topic of the day, we have talked about 4 important things. 1, breast cancer starts from epithelial cells that produce milk. 2, there are the genes in the breast that help control the 5 genes that help control proliferation and the integrity of the cell. That is BRCA1, BRCA2, TP53, human endothelial receptor growth factor, 2, PICA3CA and MYC, and 4, we have talked about cellular changes. But I've said there are some types of breast cancer according to how they come out. The cellular changes in breast, we have said, the cells proliferate, they multiply uncontrollably. they lost the differentiation, specialism. If they are supposed to be producing milk, they don't produce. They do something else. The nucleus of the cells become bigger. Loss of contact inhibition. Instead of organizing themselves in layers as they are supposed to do, they pile up, forming a very hard thing. The other thing is a version of apoptosis. The TP53 they know how to evade it, to hide, so that they cannot die. They continue living for long. And something that lives for long needs food and energy. So they start forming some things that are blood vessels that supply oxygen and nutrients by something called vascular endothelial growth factor. And that's why when you see a person has a wound of cancer, that wound is big, and if you look at it, maybe it looks bloody. The vascular endothelial growth factor there is working and producing more capillaries and veins to feed these cancer cells. The other thing is they start how to spread and to form other cancer cells that will invade other membranes to become bigger. So today's topic has been that way. If you are watching anywhere you are, if you have a question before I finish, you can ask. We have learned about why women suffer most of breast cancer than men. That one we have seen. The important note is more breast tissue and hormone sensitive. Lifetime exposure to estrogen, lifestyle exposure to estrogen, genetic susceptibility, like you can be born with BRCA, without BRCA1. In your family, you are born with this, without these genotypes, BRCA1 and BRCA2. And then we have breast cancer is linked to female reproductive biology, because the women also have a circle of a clock that revolves, menstruation, so hormones are involved, age and accumulated risk of what you do, lifestyle. You see, these are things that makes you prone to problems. You get, these are things like that makes you prone to problems. And as we say that, if you have anyone who has a question as we finish, I have 10 minutes now. Anyone who has a question, my friends, about breast cancer, there is it was a really awaited topic about breast cancer. Anyone who has a question about breast cancer? Anyone who has a question about breast cancer can ask, please. Anyone who has a question about breast cancer? Anyone who has a question, when you ask questions, it doesn't mean you don't know. It means you want to know more, and you are helping someone who has not asked that question. So breast cancer is a big topic, and you have seen so many people have died because of breast cancer. And what I may say, it's when you are having, if you see in your genetic line that some people are dying of breast cancer, and you are in that genetic makeup, the first thing you should know is maybe the genomes that are supposed to be you having, the genotypes, the ones that you have named, maybe one is not correct. So the most important thing you should do as a person, is you should avoid triggers. Avoiding triggers may make you stay away from from these problems. Kezia is here. Kezia, welcome. Do you have any question about breast cancer? Hello, Benja. Hello, Kezia. Hello, Kezia. Oh, Kezia. We are talking about breast cancer. We have had a topic about breast cancer. And if you have any question, I still have some time, like 7 minutes. Anyone that can ask any question can ask any question that anyone has can ask. But you've seen those genotypes and genomes that you are supposed to avoid and yes. Niko kwa nini? Sumpeda kwanza. Yes, we have seen those genotypes, the 5 genotypes that are very important, and they are the ones, they are the markers they are the markers of breast cancer. They are the ones which take care of the cancerous cells, and we have seen characteristics of cancer cells in breast. We have seen the characteristics of cancer cells. Join class later with everyone today. As of course, Ridley. I see Jang Hang 47. It's everyone is okay. Ridley. We have just been talking about breast cancer, and we have seen the difference between a woman and a man, and how cancer comes, and how cancer can be prevented. So if you have any question about breast cancer, it is time you can ask any question about breast cancer. At least this talk can enable people to know why some families are born with breast cancer. So you see, maybe you know your aunt has breast cancer, and then someone in your family gets breast cancer, and then you live, and then you find another generation someone has breast cancer. You see, there are some factors that we have talked about, and now you know these factors are the ones which make you have the breast cancer itself. So it is important to, but we have said even a man can get breast cancer. A man can get breast cancer. So the factors that differentiate between a woman and a man are more breast tissues are hormone sensitive in a woman. Lifetime exposure to estrogen, early puberty, monthly menstrual, pregnancy, hormones, all the hormones, sometimes hormones therapies and contraceptives. You know, there are some contraceptives that have estrogen in a woman. Genetic susceptibility. You are in your family, you have a problem with the 5 genes that we have talked about. The 5 genes that we have talked about, they are very important when it comes to breast cancer. And sometimes you may find some issues like your lifestyle. Your lifestyle can make you to start having breast cancer, because let's say maybe you are born with a low BRCA1, low levels of BRCA1 in your family, and you are drinking alcohol, you are doing things like smoking, you have a big body, and you know how they come. So you will start having what? You will start having mutated cells. And you know, mutated cells is a problem. It starts to give some cancer cells. Some cancer cells. 3 minutes go. No one has a question today. Even if you are coming late, you can ask a question. Even if you are coming late, you can ask a question. I have 3 minutes. 3 minutes to go. Anyone has a question? Anyone with a question? Anyone with any question here? Indication of genetic testing. Anyone with any question concerning breast cancer or any other question concerning medical field? Maybe you did not understand somewhere, or maybe you did not indication for BRCA1 testing, genetic. Bad boy, are you from Kenya? Yes, I'm from Kenya. I'm a doctor from Kenya. Bad boy, have you subscribed? Have you subscribed? Today we are talking about breast cancer. You just came in when time is going down. I can see Bad Boy X. Yes, I'm from Kenya, Bad Boy X. I am from Kenya, and here we talk about medical issues. So, hit the like button, subscribe a bit, so that at times when there is a topic that you need to follow up, you can be checking, and then here we continue discussing. I am in Thika, bro. I am in Thika. Oh, okay, that is nice, Bad Boy. Hit the like buttons. Let most likes, like it makes you be part of the team, and it gives impression. So like. Do you have any medical issue, Bad Boy, that you can ask before my time ends? Anything medical, anything. Although today we have been discussing about breast cancer before power disrupted us. So you can ask anything, Bad Boy, any question, but don't leave without subscribing. Your subscription and like of this chat is important. I know Thika is a big town. It's a big town. There are several institutions there that I know. There are several institutions, hospitals, heart centers, universities there. Yeah, can you send me something for Saka Comrade in Thika Tech? Oh, you are in Thika Technical. Which course are you taking at Thika Technical? Thika Technical is a vocational study center. Oh, plumbing. Which year are you? Plumbing. We can link up. When you finish, I can give you some jobs. So what you do, Bad Boy X, next time kindly talk about hormonal and non-hormonal contraceptives. Kezia, okay, we talked about them, but I'll still talk about them. Under breast cancer, we will talk about hormonal and non-hormonal contraceptives when it comes to activation of the cancer cells. Plum Boy X, what you do, subscribe, go to one of my videos, leave there a note, then we can talk, we can link up. It's good to connect, so that you are a plumber, you are still a student, you need some pocket money. Maybe I get someone who needs a handman in plumbing. I can connect you to that person. When you are a student, you need you need to have experience. So when you are doing experience, Okay, Plumbox. Plumbox, there are some moderators. When you come to the chat with such, I've already told you to connect with me, and some on my chat. If you take some more things, you will see someone removing them. So don't continue insisting. Some moderators may remove your chats, and it's not good. It's not good. It's not good. Plumbox. A moderator may remove your. I will link up to you. I own up to my now. I will. Okay, so Kezia, under breast cancer, we will talk about this hormonal methods and non-hormonal methods. Don't worry, we will talk about hormonal and non-hormonal methods. And before I log out, what I really want everyone to know is BRCA1 and BRCA2 in genetic makeup is the most bigger problem when it comes to genetics to people who are suffering breast cancer problems, to people who are suffering problems. So if you have a problem in your family about that breast cancer, and so please always, when you go to hospital, try and talk to your doctor to run this test so that you can know. So tomorrow we will continue with the breast cancer problems, and we will know more about breast. Today we have you have to know the normal and go to the abnormal. So what I've done today, I've given you how the normal is, how you can your epithelial and your breast are protected from cancer, and I've given the genes that help. And then I have given you the characteristics of a gene that is a breast that has a problem and how it shows up. So tomorrow we'll continue now deep to the cancer itself. We see how the cancer, the 5 types of cancers, how they come up. With all due respect, my people, let's stop there for today. We'll be meeting Jamaican Uncle later as we talk. But if you have any question that you will need to ask at any time, you know how you can reach me. Tomorrow we are continuing with breast cancer, and have a lovely day where you are. Nice evening, nice day, nice lunch, and good night, depending with everywhere and every person is. Bye. See you tomorrow at 16:30, my normal time. But when there is an emergency and we really need to talk about something, we come at 10 o'clock at night. Bye. See you tomorrow.